Implicit differentiation. Derivative of x, derivative of y is what? It is dy over dx. So what will be the derivative of y to the power of n? It is going to be n times y to the power of n minus 1 times dy over dx. In implicit differentiation, when you take the derivative of y, anything with y, any expression with y, you are going to put dy over dx there. So if we have y cubed, what will be the derivative? 3y squared times dy over dx. And what is the meaning of implicit? Implicit means x and y are side by side. Before passing to that, let's remember, what is derivative of u dash v? Quotient product rule. It is u dash v plus v dash u. What is derivative of u over v? It is u dash v minus v dash u over v squared. And let's remember another thing. If we have a to the power of x, what is the derivative of a to the power of x? It is a to the power of x times ln a. These are the rules that we have to remember before starting implicit differentiation. Let's start with a simple example. If we have x times y as an implicit expression, let's take the derivative. What do we have here? We have a product, x times y. So derivative is going to be derivative of the first one, which is 1, and times the second expression, plus derivative of y, dy over dx, times x. So derivative of x times y is 1 times y plus dy over dx, which is equal to y plus x dy over dx. Now, let's have a much more complex example. If we have e to the power of x times y cubed and its derivative. Again, we have a product here. So we are going to apply the product rule. What is derivative of e to the power of x? So let's change this one to e to the power of 2x. What is derivative of e to the power of 2x? 2e to the power of 2x times the second expression plus the derivative of the second expression. Here we have to be very careful because derivative of 3y cubed is 3y squared. And remember, in implicit differentiation, after taking the derivative of anything with y, we have to put dy over dx there times the first equation. Okay? That's the important part there. If you take derivative of anything with y, you have to put dy over dx there. Now, e to the power of 2x is common. In the brackets, we are going to have 2y cubed plus, y squared is also common. 2y plus 3 dy over dx is derivative of that expression. Let's carry on. Page 2. Let's have a longer example. If we have such an implicit expression, implicit means again x and y are side by side. The question is, for part A, find dy over dx. Let's find dy over dx. So we have to differentiate 2x squared plus 4y cubed minus x plus 4xy minus 6. What is derivative of 2x? 2 times x squared, it is 4x. What is derivative of 4y cubed? Here we have to be very careful. 4y cubed is going to be, derivative of 4y cubed is going to be 12, 3 times 4, 12y to the power of 2. Because we took the derivative of an expression with y, we have to put dy over dx there. You have to be careful about that. Then derivative of minus x is minus 1, and we have a product here. We have 4x, then y. So we have to apply the product rule. Derivative of the first one is 4 times the second expression. Derivative of y is dy over dx times the second expression, first expression, which is 4x. Derivative of we have 0 there, sorry. Yes, we have 0 there. Derivative of 6 is 0, and derivative of 0 is 0. So this is equal to 0. Now, what do we have? 4x plus 12y squared dy over dx minus 1 plus 4y plus dy over dx, 4x is equal to 0. Now I am going to move that one, and that one to the right hand side because they don't have any dy over dx nearby. So, and put 12y squared plus 4x in the brackets and dy over dx there. Move them to the left side, right hand side, minus 4x plus 1 minus 4y. So dy over dx is going to be minus 4x plus 1 minus 4y over 12y squared plus 4x. Up to now, do you have any questions? Up to this point, do you have any questions? No. Okay. Please open your books. Page 56. I want you to open your books, page 66, 56. Now, page 56 from your International A-Level book, question 3, part H. Find dy over dx when e to the power of x times e to the power of x times y is equal to x e to the power of y. What is dy over dx? This is the question. Now, e to the power of x times y is equal to x e to the power of y. Take its derivative. On the left-hand side, we have a product. Let's apply the product rule. Derivative of e to the power of x is e to the power of x. Derivative of times y plus derivative of y, which is dy over dx, times the first expression, e to the power of x. Let's do the same thing for the right-hand side part. Right-hand side part of the equal sign. We have another product there. So derivative of x is 1 times e to the power of y plus derivative of e to the power of y is e to the power of y dy over dx. Remember that one there. Times x. So e to the power of x times y plus e to the power of x dy over dx is equal to e to the power of y plus e to the power of y times x dy over dx. I am going to take that one to the right-hand side and that one to the left-hand side. Simple algebra here. E to the power of x dy over dx minus e to the power of y x dy over dx is equal to e to the power of y minus e to the power of x times y. Let's take dy over dx in the brackets, e to the power of x minus e to the power of y times x in the brackets, which is equal to e to the power of y minus e to the power of x times y. So dy over dx will be equal to e to the power of y minus e to the power of x times y over e to the power of x minus e to the power of y x. This is the answer for that one. Let's have another question here from the same page. This is our third page. Question 7. I am going to solve question 7. A curve is described by the equation 2x squared plus 3y squared minus 6x plus 6xy plus 5 is equal to 0. The question says, find an equation of the tangent to C at point 1 minus 2, giving your answer in the form of ax plus by plus c. So to be able to find the gradient of the tangent, we have to find dy over dx. So let's find dy over dx. We have to differentiate the whole expression to be able to find dy over dx. So what is derivative of 2x squared? 4x. Derivative of 3y squared? 6y dy over dx. Derivative of minus x, minus 1. And we have a product here, 6x times y. Derivative of the first derivative of 6x is 6 times y. Derivative of y is dy over dx times 6x. Derivative of 5 is 0 and derivative of 0 is 0. So 4x plus 6y dy over dx minus 1 plus 6y plus 6x dy over dx is equal to 0. dy over dx in the bracket 6y plus 6x is equal to minus 4x plus 1 minus 6y. And dy over dx is equal to minus 4x plus 1 minus 6y over 6y plus 6x. We have to find the gradient of the tangent at point 1, minus 2. Here x is 1, y is negative 2. So gradient of tangent line is going to be minus 4 times 1 plus 1 minus 6 times minus 2 over 6 times minus 2 plus 6 times 1. Gradient of tangent is going to be minus 4 plus 1 plus 12 over minus 12 plus 6. So M tangent is going to be 9 over minus 6, which is minus 3 over 2. So equation of tangent line is going to be M tangent x plus c. Let's substitute M tangent there. Y is equal to minus 3 over 2x plus c, which passes through the point 1 minus 2. Minus 2 is equal to minus 3 over 2 times 1 plus c. So c is equal to minus 1 over 2. Y is equal to minus 3 over 2x minus 1 over 2. Multiply the whole expression by 2. 2y is equal to minus 3x minus 1. And we are going to write this one in the form of 2y plus 3x plus 1 is equal to 0. And this is the answer for question 7. Now, I am going to solve question 10 on the same page. Question 10 says that we have a curve with equation sine x plus cos y is equal to 0.5, and the range for x is minus, it is minus from minus 5 to pi, and also the range of y is from minus pi to pi. Find an expression for dy over dx. The question is, says find dy over dx for the first part. So sine x plus cos y is equal to 0.5. Take the derivative. What is the derivative of sine x? It is cos x. What is the derivative of cos? It is negative sine y, and because we took the derivative of anything with y, we have to put dy over dx there. What is derivative of 0.5? It is 0. So cos x is equal to sine y dy over dx. So dy over dx is equal to cos x over sine y. And part B says find the coordinates of the stationary points. That means for stationary points, dy over dx has to be 0. So cos x over sine y has to be 0. That means for the numerator to be equal to is 0. Cos x is equal to 0. This is the graph of cosine x. We have to remember that. This is pi over 2, and that point there is pi over 2. So x is negative pi over 2 and x is pi over 2. Do you have any questions? So these are the x values. Let's find the corresponding y values. What was the equation? Sin x plus cos y is equal to 0.5. When x is equal to minus pi over 2, sin negative pi over 2 plus cos y is 0.5. What is sin negative pi over 2? Let's remember the sine curve. And this is negative 1 plus cosine y is equal to 0.5. Cosine y is equal to 1.5. No answer for that. So when x is equal to pi over 2, sine pi over 2 plus cosine y is equal to 0.5. This is 1 plus cosine y is equal to 0.5. Cosine y is equal to negative 0.5. So y is equal to let's use the unit circle here. We have one of them there, the other one there. And cosine is minus 0.5 when angle is pi over 3. So y is equal to 2 pi over 3 and negative 2 pi over 3. So the coordinates of the turning points are pi over 2, 2 pi over 3, and the other one is pi over 2, negative 2 pi over 3. Do you have any questions?
Yok hocam.
Yes. And the homeworks are finish question 3, do question 4, 5, 6, and 11. 3, 4, 5, 6, and 11. Okay?
Okay hocam.
On the same page. We are going to meet on today is Wednesday. We are going to meet on Friday. Okay? Again at 9 o'clock. See you then. Bye bye.
Bay bay hocam.
Bay bay hocam.